Okay, so y, snap. Y equals, I'm sorry, what? Okay. So absolute value, this is an equation that is going to be graphed on the coordinate axis. And we know that because there's an x and a y in this problem. Okay? What you need to remember and keep in mind that this is not a linear equation. It's not in the form of y equals mx plus b. What it is that what does an absolute value do? It makes everything after we've simplified inside it what? Positive. So it is symmetrical the way a parabola is symmetrical. Okay? It's a v. An absolute value is a v. The big thing that you want to remember, and some of you wrote this on your homework because you did some research, was this. Okay? This is your general form of a absolute value function. M is your slope. And like a parabola, it determines if it opens up or down. Obviously, if M is positive, your absolute value function opens up. And if it is negative, then it will open down. Okay? Your vertex is going to be h comma k. Now notice, this is saying minus h, but what we're using is the opposite of whatever sign is in here. So if this was x minus 3, then we would use 3. If it was x plus 2, we would use negative 2. So it's the opposite sign of what's in here. Does that make sense? This sign is always the same. Whatever this is, plus 3, plus 3. So what is my understood slope to be in this problem? 1. And is this a positive 1 or a negative 1? So will my absolute value open up or open down? Okay. What is my vertex? It's a point. What is the x value? Okay, so it's positive. Okay, it's the opposite sign of whatever's in here. And what is my y? Correct. There's nothing out here, so you can always add 0 to anything without changing it. Okay. So 1, 2, 3, 4, 5, 0. This is going to be either the max or the min of the absolute value function. My slope was 1, correct? So basically, because it's positive, we're going to start by going up 1. And then because it's symmetric, as a fraction, we want to think about this as 1 over 1, correct? So we're going to go up because it's positive, and then left 1 and right 1 because these points are always symmetric. And there's the v. So for example, if my slope had been 2/3, I would have gone up, what? 2, and then left and right, what? Exactly.
Wait, can you explain that again?
What part? The vertex part?
Yeah.
So the vertex, so the slope, this is your slope, whatever's out here. If there's nothing there because we're multiplying, we put a 1. Okay? I know that 1 is positive, so I know my absolute value has to open up, which means my first direction that I do is going up whatever the units are. So I think of 1 as 1 over 1. So from my vertex, I go up 1 unit, and then because it's symmetric, I go my denominator, both left and right 1.
Oh, okay, okay.
Okay, what was the next problem? So plus 0. Would you all agree it's just plus 0 hanging out there? Okay. What is my slope? And as a fraction, we would say then it is really? And is it positive or negative? And so what direction should my absolute value v open? Okay. What is my vertex? Are we comfortable with that? Okay. Here's 1, 0. From this point, I travel what? Up 3 and then left or right 1. So up 3 and then right 1 and left 1 from that up movement. Yes? Athena?
So, like in
They're just showing you, Athena, from the parent V, which is at the origin, how you're moving it. That's what they were showing. All right, so what's the last one say? Y equals what? Okay, so you try this one. Put this information down, and then try graphing it. Tell me the slope. Tell me the vertex. Tell me the direction. So, is this what y'all got? So I went, my vertex was 3, 6, right? And then I went up 2. So that would make it an over 1. So that would be 2, 8, and yes. Well, you probably did not pick a point and reflect it. I'm always coming up with my reflection points.
Yeah.
Okay. Was there one more? Was that it? Are we good with this now? So corrections for this parabola first part due tomorrow. Put it away for right now. If you've got questions, come in during lunch, the second part, or after school, and I'll help you some more, okay? Now, let's go on because we are limited with the amount of time, and let's look at day 2. Are we a little bit better with day 1 now? Thumbs up, thumbs down. Are we better? Okay. Huh? I can give you more practice, yeah. There's also a whole bunch of problems in the back of the book for every section. Okay. And I do think check Moodle because I think I put a whole bunch of extra problems for chapter 4 on there too.
The extra practice problems in the back of the book, they're the odd ones that you use are also in the back of the book.
So you do have some places. Okay? All right, so take a look. If you're use your highlighter here. Okay, if you're on your computer, do your screen flat, please. Thank you. You've got 2 other forms. The first form that we learned yesterday was called what form? Standard form. No matter what form you're given, all right, however it's presented to you, you are always guaranteed 2 pieces of information. Now, what 2 pieces of information will vary from the way that it's given to you. In standard form, we were guaranteed the direction, and what else were we guaranteed to get? The y-intercept. What do you think you're going to be guaranteed to be given in the vertex form? The vertex, and then also, yes, the direction, okay? And if I give you the intercept form, what do you think you're guaranteed to get beside the direction? Now, careful. It's the x-intercepts, not the y. So in the intercept form, you're given x-intercepts. It will. If I'm giving to you an intercept form, I'm giving it to you with 2 x-intercepts. Okay? So x-intercepts are given here. Vertex is given here. In addition to the direction that it opens. Make sense? All right. Now, whether it opens up or down, In either case, it's determined by this A, whatever sign is in front of your parentheses. So if A is positive, guess which way it opens? Up, and if A is negative, it opens. Okay? All right. It's kind of a good thing that we went over absolute values because the way we find the vertex in the vertex form is the same way in a parabola as we did right now for the absolute value. Okay? So for number 1, we're going to determine the direction. What is my direction? We know that's up because 1/2 is positive. Okay? Now we know immediately what we can figure out to be the vertex. Just like we did right now with absolute values, what is my vertex going to be as a point? 3, -4. Opposite of whatever's in parentheses with the x, same sign whatever's hanging out here to the right. So steps are going to be a little bit different, okay, in this one, but basically you're still having 5 steps. Just the order. Whatever's given to you initially is what you can find, what you're going to write first. Grace? Because we're really setting this if it equal to 0. Does that make sense? All right. So now if we know the vertex, what's the next piece of information we know that we can come up with? Perfect, which means x is equal to? Okay. So let's start. We're going to get our handy dandy red pen. 3, 1, 2, 3, 4. Well, that didn't come out red. Let's try that again. Still didn't come out red. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. I'm having issues. Okay, axis of symmetry. Okay, so I'm missing at this point what 2 pieces of information? So we don't always have to go directly to the y-intercept because in the no-b method we had to find another value, right? But we had to reflect it, correct? So at this point we're going to do the same thing that we did for the no-b. We're going to do a little chart, and for step 4 and 5, we're going to create a point. It doesn't matter what value I let x be, does it? No. However, in this case, we want to pick something that when I take 3 away from it and I square it, it will cancel with this 1/2 that's sitting out in front. Do you understand that? So that I have something pretty. Okay? So maybe I'll use, sure, 5. If x is 5, then in here I get 2. And then what do I do next? I get 4, and then times 1/2, and I get back down to, and then subtract 4, and I get. So my next point that I'm going to graph is 5, 2. And where do you think this reflection point is going to be then? Why are we, oh, did I plotted it wrong? 5, -2, so 1, -2, yes. What is wrong with this? There we go. And we've got our pretty parabola. 1, -2. Well, we know that V's are absolute values. Okay. All right. Are we comfortable with this one? Yeah. All right. I'd like you to try this next one. No, I forgot. But what is the min or the max? What is this one? Minimum. And what is the value? It's the min or the max is determined by the y value of your vertex. Okay, so you do the next, do the graphing, find the min and max. Is this a little easier today with this problem now that you've already gone through the 5 steps from yesterday? You might want to make yourself a little cheat sheet of the 3 different types to kind of have it handy, but remember, you're going to know those for the quiz on the 9th. You can make X whatever your heart desires in this case. Oh, okay. But you can't make it 2, because 2 is already taken care of. Right? You're going to get the same point. Assuming you do the math right. I know. So when you come up with your chart, I really don't care what number you pick. You could have picked 1. If you would have picked 1, you would have gotten -2, which would have given you 3, -2. Does that make sense? You could have picked it -1, and then you would have reflected it. So these, as long as they make sense in your problem, your point and your reflection, I don't care what points you use. Haley?
Are we supposed to find a y-intercept for these problems?
No?
We don't need to find a
Mm-mm.
y-intercept.
Because it's not given to you.
Okay, yeah. I don't know why I thought we...
Kathleen, question or stretch? All right. So, raise your hand if you got this right. You can have different ones here. Yes. Perfect. Awesome. Next one. So this method is called the what? Do you see the difference?
I have a question.
Yes.
Oh, they're not the same. Okay, because in your, formula, can you go for a second? Doesn't it say PP?
So yeah, they're not the same. They're not. They don't have to be the same. No.
Alright, I thought that would mean that they were...
Okay. So why do we make this? So,
Why did she use it here?
why don't we do an A or just change that so that it's different? Okay. It takes so little to make you guys happy. Okay. Oh, max or min? What's the value? All right, that's what I'm looking for here. Right? All right, so this is the intercept method, which means we're given, actually, in this case, 3 pieces of information. Okay. The direction is what? And we know that because? That A is where? It's all the way right in front of this first parentheses, right? There's nothing there. Really, even if it was negative, it'd still be -1. So you're just looking to see if that part is positive or negative. Okay? Okay, what kind of intercepts did we say this was? So, in general, how do you write an x-intercept versus a y-intercept? Number, comma, 0. Right? Y-intercept is 0, comma, your number. So an x-intercept is, okay, we're going to go x, comma, 0. That's how you write an x-intercept. You've got to understand that. So then, how many x-intercepts do I have? One of them, which is, comma, 0. And the next one, which is, no, 7, comma, 0. Because we're setting x, aren't on it. Right? Intercepts are when you set something equal to 0, correct? Okay. This is algebra. We're in algebra now. Okay. So guess what happens with 3? 1, 2, 3, 0. What do you think those 2 points are? They are reflections of each other. Right? They are reflections. So I'm going to add, wait. Hold on, Rachel. So what direction does this open? Where are you going to find that vertex? Above those 2 points or below those 2 points? So this is the things you have to think about. And don't just kind of go through the process of doing these problems again and again and again. Think about what you're looking at and what's given. Where, and I want you to raise your hand and not yell this out, where are you going to find the x value of your vertex? If these 2 points are reflections, where should that vertex, that x value of that vertex fall? Maddie? Average. Good. Also known as, if we talk about it in not statistical terms, but in mathematical terms, it is the midpoint. And how do we find the midpoint? No, we don't count. We do not count. Average or midpoint, add and divided by 2. I'm not going to make them all pretty. We're not going to add. 7 plus 3 over 2, 5. You have just found the x value of your vertex. How do you find the corresponding y? Plug it in, plug it in. Okay. So y is equal to, parentheses, 5 minus 3, parentheses, 5 minus 7, 2, and negative 2. No. What is this? And these should usually be I think the same. So that's negative 4. Would you agree? So this is 5, negative 4. We said it should fall below those intercepts, and lo and behold, it does. And hold on. I don't. What's wrong with this thing? 1, 2, 3, 4. Oh. Nope. Fractions are not illegal. X equals what is your axis of symmetry? And minimum or max of what value? There you go. Are we good? Making some sense? So much easier, I know. All right, you try the last one. Are you sure there aren't any fractions?
Okay, looking at the problem, there aren't any. That's all that matters to me.
Okay.
It stinks when you start out with fractions. And then you just have a bad feeling about the entire fraction.
All right, we're running out of time, so finish up. That's why you have a calculator.
You shouldn't be teaching us this.
Absolutely.
No, because I got to that math competition and I was like, oh.
I know.
No.
Let's finish this up. So what is this? What is this all going to be? So your intercepts are 4, 0, and negative 1, 0. And our midpoint is 4 plus negative 1 over 2, which is 3 halves. So then I'm going to do 1.5 minus 4, which I believe is negative 2.5. And 1.5 plus 1, which is positive 2.5. Multiply that times negative 2, and what do I get? I don't know. 12.5?
Someone do it.
All right, Caitlin, do it for me. What's 2 times 2.5 times 2.5?
Yeah. 12.5.
Okay.
Oh.
Yeah. Okay, so now we are at 4, 0,
Okay, so you can go down.
1, 2, 3. Oh. 1, 2, 3, 4. Negative 1, 0. My vertex is at 1.5, 12.5, which is like right up here. Hold on. What's my axis of symmetry?
That's your perspective.
X equals 3 halves as an equation.
The maximum value of 12.5.
Yep. Maximum. Are we good?
So good.
All right.